In this video, we'll be going over skill 1.2 from the diagnostic functional analysis. The very first question here asks, what is the domain of this function? So if I'm looking at my function, I have three different pieces. If I start transferring these pieces to the x-axis, I have a solid dot on -7, an open dot on -5 from the first piece. When I look at the second piece, I'm going to fill in the -5 from this point up here. And then I'm going to go all the way to -2 with an open dot on -2. Everything is included in between. That's going to be one piece from my domain. So if I write that, that's going to be from -7 with a bracket because it's a closed dot to -2. That's a parentheses because it's an open dot. Let's see if I can erase that just so that it doesn't clutter this up. And then if I look at -2, so right here, there's nothing else, no other x values included until I hit this third piece over here. So looking at the third piece, I've got an open dot on +4 and a closed dot on +7. Everything is included in between, so I can color that in. That's going to be my second piece. So I'm going to have parentheses 4, comma 7, bracket. And again, I'm just going to delete that so it doesn't clutter this up. Moving on to the next question, what is the maximum of this graph? The maximum is the highest y value on the graph. So we would say f of x equals 4, or we could say y equals 4. It's not the point, it's not the ordered pair. When it says maximum, that's referring to the highest y value, or the biggest y value. Okay, this next one is a little bit complicated. So this part's asking about where the interval, where f of x is positive. And positive means where the y values are bigger than 0. So where the y values are positive, that happens right here and right here. For this one, it's easy because it ends on a whole number. It goes from +4 to +5. So we're looking at the x values here. I could go ahead and fill that in. So I have +4 to +5, and I'm going to use a parentheses on the 5 because even though this point is included, it's a 0. It's not included in the positive interval, it's just included in the graph. When I come look over at this one, the lower bound is easy to identify. It's this -5. And that one is a closed dot. It's not a 0, so I can use a bracket. But when I come to look at the 0 isn't a whole number. So I'm going to need to solve and figure out what that is. So I'm going to come down here and do some scratch work. In order to solve, I'm going to need to know the equation of this line. So if I look at this, first I'm going to find the slope. If I'm moving from this point here to this point here, we have to go down 3 over 1. So my slope is going to be -3 over -1. I mean -3 over 1, which is the same thing as -3. In order to finish up the equation of the line, I just need a point on the line. If I use this point over here, that's going to be x plus 5, because it's x minus x1. Plus 4. Okay, so right now I'm using slope-intercept form, which is m times x minus x1 plus y1. If I work on simplifying this, I'm going to use the distributive property here. So we have y equals -3x minus 15 plus 4. That's y equals -3x. -15 plus 4 is -11. And then let me make this a little bit smaller. If I add 11 to both sides, we're going to get 11 equals -3x. Divided by -3, we get x equals -11 over 3. So I'm going to, in my space here, I'm going to write -11 over 3 is the 0 of the function right here. And I actually skipped a little part, made a mistake here. When I started solving too quickly. at this step right here, what I really did here was I substituted in a 0 for y, because that's what a 0 is. It's the x value that makes the y value 0 on a graph. So this step was actually critical, and I accidentally just did this in my head instead of putting it down on my piece of paper. Next. So the next question asks, over what intervals is f of x decreasing? Decreasing means the y values are getting smaller. They're going down. So I'm looking at this part of the graph and this part of the graph here. When I report this answer, I'm going to report x values. Almost everything gets reported in x values. So that's -5 to -2. I'm looking here at whether the points are included or not included. And that's going to also include the interval from 4 to +7 for decreasing. The next question asks about both positive and decreasing. So I'm looking for spots on the graph that are going down, but that are above the x-axis. It just so happens on this particular graph that this answer corresponds exactly to the answer for where the graph is positive, because both places where it's positive, the graph is also decreasing. So here I can just copy my same answer from part 3. It's going to be -5, -11/3, and 4, 5, with the appropriate parentheses or brackets. And now we've just got one question left. The last question is about average rate of change. Average rate of change, remember, is the change in y over the change in x. It's how much the y variable changes every time we change the x variable. So I'm looking for an ordered pair where I can either use the slope formula, y2 minus y1 over x2 minus x1, or average rate of change can also be found by calculating the slope between 2 points. Well, that's what this formula is, but we can also do that on the graph doing rise over run. So if I'm looking at the interval from -5 to +7, these are my x values, my x1 and my x2. So I'm going to come up here to the graph. At -5, I have the point -5, 4. And when my x is 7, I have the point 7, -4. So if I'm doing rise over run between these 2 points, I have to go down 8 and over 12 to get there. So that's down 8 over 12. And I can simplify that to -4 over 6. And I can keep going to -2 over 3. Could have done that in one step easily. But what I really have just calculated is the slope between an invisible line that passes through those 2 points.